Thanks, Ranjita.
Thanks a lot, Stefan. Well, since Microsoft Research India got set up, there's another Microsoft Research Lab that got set up in New England, so we're no longer the youngest lab. They stole our thunder.
They're a theory lab.
Yeah. Yeah, that's right. So I'm going to be talking about some work I've done over the last year at Microsoft Research India on home network diagnosis. But before I go to that, I thought I'd just throw out a few slides describing Microsoft Research India in general, because people really don't know that much about it yet. That's a picture of our lab there. It's nice, green and shady. It was established in early 2005, and it's part of the worldwide network of labs that Microsoft has. And the goals are similar to any other Microsoft research lab, which is high-quality research, do tech transfers to business groups within the company, and to do external collaborations and service. Actually, this one is particularly important to us in India because one thing that Microsoft Research India tries to do is encourage more graduate students in India, encourage people to go do research in the IITs, in the Indian Institute of Science. So that's really important. And as part of that, we have organized a networking summer school in June 2009, where we've invited people from different universities in the US and in India, and also in England. And these folks are going to come and talk about things in their expertise. So George Verghese is going to talk about internet algorithms, for example. He's going to give a class, and lots of students from India are going to attend that. We're also going to be instrumental in organizing SIGCOM in 2010 in India, just a heads up for everyone. We have around 50 full-time technical staff. So we have researchers, we have postdocs, and we have a program which is best described as pre-docs, really. So these are assistant researchers who, just after finishing their BTechs or MTechs in India, join our lab for 2 years and then go on to do graduate studies or whatever they prefer to do. We have software engineers as well, and we have lots of visiting researchers and lots of interns. So we had 80 in 2008 alone. For 50 full-time technical staff, that's pretty big. Our research areas are mainly divided into these 7 categories. So algorithms is our latest group, which was started by ex-professor from Yale called Ravi Karnan, and he's started this group, and he does something called 21st century algorithms, which I really don't know anything about. Then there's crypto, security and applied math, digital geographics, mobility networks and systems, which is the group I belong to, multilingual systems, rigorous software engineering, which is another group which does stuff is related to networks and systems, and that's sort of probably the work that's closest to networking and systems, other than what gets done in the MNS group, or the Mobility Networks and Systems group. And then we have the Technology for Emerging Markets group, which is trying to bring together sociologists, anthropologists, economists, and technologists in different ways. And to bind all this together and to see how the research can actually move to products, we have the Advanced Development and Prototyping group, which can take some ideas from research and just develop it further before handing it over to product groups or business groups within Microsoft. This is the MNS group, and I won't go into too much detail here, but we have 4 full-time members right now. There's me, there's Vishnu Navda, who does wireless networking, energy-aware Wi-Fi stuff right now. There's Venkat, who's our research manager, and he's done lots of stuff in the past, and he continues to do lots of stuff. Ramji joined us from Bell Labs, and he's working on this WAN acceleration work on how to improve bandwidth usage between, say, the main office of a company and branch offices. We've had visiting researchers in the past. Kameshwari Chebrolu and Bhaskaran Raman from IIT Mumbai, and Jeff Volker visited us about a year and a half ago. And like I said, we have lots of interns. In spite of just having 4 full-time faculty, we've had 19 interns in the last 2 years. and some of them from the US and some of them from India. So the interns we get from the US are mostly PhD candidates, and from India, because we have such a great undergrad program in India, we get lots of great undergrads from just finishing their third year in school. And the assistant researchers, where we have what we call graduated assistant researchers. So they've, so far, our record with getting them to go to graduate school has been 100%. So Ganesh is at Berkeley, Lenin is at MIT, Prashant has a choice between Berkeley, UW, and UCSD, and we'll see where he goes. All right. So these are our main concentration areas. There's network management and performance, which is what I'm going to be talking about. One of the projects under that is what I'm going to be talking about. It's called NetPrints, and the main idea is to simplify home network configuration management. And this is a paper that we're going to be presenting at NSDI 2009. Other than network management, we also have wireless networking, mobile and sensor systems, and some system analytics work. And I'm just going to postpone discussion on that. And if anybody is interested in any of this work, please do come and talk to me after this, and we can take it from there. All right, getting on to the actual technical content of my talk. NetPrints is a project for diagnosing home network misconfiguration using what we call shared knowledge. And this is joint work with Bhavish Agarwal, TD or Tathagat Das. Siddharth Ishwaran was an intern who worked with us over last summer. He's an undergrad at IIT Mumbai. Venkat and Jeff, when he was visiting, was also part of this work. Before I actually go into describing NetPrints, I'd just like to motivate the problem we're trying to solve and explain what the problem is. So a typical home network these days consists of a large number of components. There's different kinds of applications. There are, VoIP applications, email, file transfer, remote desktop, et cetera, And there are all these network components. There's desktops and laptops. There's host-based firewalls, NAT routers, and also the modem. So in general, you have, this huge number of heterogeneous components out there, and really, what makes the problem even more difficult of managing this whole mess is that there's no network admin. There's only a home user who's not necessarily very conversant in how to go about administering. Yeah.
So everything, though, here that you described as a computer, do you also consider the situation where you have your TiVo and your streaming MP3 player and so forth? Because I think that adds an additional level of complexity, because those are embedded devices that you can't log into or change anything about. They just
Right.
are.
Right. So I'll just repeat the question. The question is, can we extend what I just talked about to devices as well? And as we know, the number of devices in a home network is also going up. You could have gaming devices, your TiVo, your media players, all that kind of stuff. Well, the answer to that question is yes. In general, at a philosophical level, you can do everything. Not just at the philosophical level, but even, if the problem is to do with the home router, which it very often is, or the NAT box, or the modem that you're using, then NetPrints can actually work, because we've actually tested our system with the Xbox device and have shown it to help in certain cases with the Xbox. So I'm assuming if we had done our experiments with TiVo or Slingbox or any of these cool things, we could have shown it to be of use. So what we did initially was go online, look at forums, look at the different kinds of problems that people have in home networks. And here's just a sampling of some of the problems. And I don't expect you to go through each one of these, but I'd just like to bring to your attention that these problems are all very different. So this first set that I've outlined here, the VPN client that people are trying to use does not connect because there's some firewall parameter, the PPTP pass-through parameter on the home router that needs to be turned on or something like that. So there are all these router changes or router misconfigurations that can create problems for people. Then there are problems like these. So file sharing doesn't seem to work because you haven't made sure that you and the file server are on the same domain or work group. You're in one domain, the other machine is on another work group, and so the authentication is not set up right, and you run into a problem. So these are examples of end host misconfigurations. And the third classification we have, which is this particular problem here, that some people could not send large emails because, well, the problem really was something on the remote side. On the server side, packets were getting dropped because the packet MTU size was too large. But then you could make a local change. You could change your MTU value to something much smaller and things would work. So you have these remote problems, but local changes will actually fix your problem for you. So as you can see, there's a lot of diversity in the kinds of, and this is just a small sampling of problems. There's even more diversity. So that makes the troubleshooting problem even harder. So what do users do today when they run into a problem? They can go to the help system, go to the Microsoft website, search the internet, look up a magazine, ask a friend, all of these things, right? And these are results from a survey in 2004. And this survey said that only 55% of the people really had their problem solved even after all of this. Yeah, question?
Do you have results over which of these led them to be resolved?
No, I don't have that. Yeah. So like I said, these are old results, but from just talking to folks within Microsoft and even, just going out there, I keep looking at forums, to see what are the latest problems that are being reported. And I'm not seeing this number increase by any amount. So that's why we came up with the idea of NetPrints. We saw there was this void in this space. So we said, what could we do about this? So NetPrints is a system that tries to automate problem diagnosis, of the form that I showed in the previous slide, using what we call shared knowledge. And this slide sort of describes at a very high level what I mean by that one statement. So we have this NetPrints cloud service running somewhere, and we have people subscribe to the NetPrints service. And they could be geographically well separated, in India, in Europe, in the USA, etc. And they contribute configuration information to the NetPrints cloud service. And they say, I'm running this VPN client, and this is my configuration, and I don't have a problem. It's running normally. So that when somebody else comes up and says, hey, I'm using this particular VPN client, the same VPN client, and for me it's not working, can you help me? They can send their configuration to the NetPrints service, and the service can suggest some changes which might actually fix their problem. Now, why use this approach at all? There are products out there that do diagnostics for you. There's Windows Network Diagnostics Framework. There's Network Magic, which is now, I think, provided by Cisco. And Apple also has diagnostics frameworks. But what they do really is resolve basic connectivity issues. Say your wireless switch is off on your laptop, or your Ethernet cable is not plugged in, or your DNS is not configured correctly. These guys actually have rules that test for these scenarios specifically, and they say, oh, I tried a DNS request, it didn't go through, so your DNS server must be wrong, things like that. So these sort of rule-based approaches or targeted approaches can work for some basic connectivity cases where you just don't have any network connectivity, but the coverage is pretty low. And then there are all these learning-based techniques in the literature, things like peer pressure, which was presented a few years ago at OSDI, Autobash, and then the SVM-based performance debuggers. And these use this whole concept of bringing together a lot of configuration information and learning from that configuration information to resolve issues. But they're targeting mainly problems in the Windows registry or things like that. So we really said, why not take some of these ideas and apply it to networking problems or home networking problems in general. So that's how the idea for NetPrints came about. But it's not just that easy. You can't take a known learning technique or whatever peer pressure did and apply it to these networking problems because of a number of reasons. First, there's a lot of distributed configuration information out there. There's configuration on your end host or your client, and then there's configuration on the server you're trying to connect to, and the problem might be on that remote side. Then there's the modem, the router, different devices. So you need to write different kinds of configuration gatherers or scrapers to get all this configuration information. Next, the problem can be caused because of interactions of different configurations. Like I said in a previous slide, an MTU mismatch can cause a problem. Your configuration on your local machine itself is fine, but when you try to put it together with some remote machine, some combination starts causing a problem for you. So we got to consider those sort of scenarios as well. And another thing I'd like to bring out in this slide is that basic connectivity issues, we think that rule-based techniques can actually solve quite well. Even though right now the coverage is pretty low, but we still think rules to check things like your DNS address and whether DHCP is working or your cable is plugged in will still work. The problem is really when you have an application-specific problem. Your VPN application is not working correctly, or your Xbox device does not work. There are just so many applications out there that writing a rule for each of these applications for each and every different way it fails is it's pretty difficult to do, or we believe it's difficult to do. So let me just give you an idea or a scenario that describes how NetPrints really works. And this is pretty much how our prototype works right now. So you have this laptop, which is connected through this WIRT54G Linksys router to the internet. And let's say I run this laptop and I'm subscribed to the NetPrints service. Now, I'm going to assume that there's some training data for this specific router already sitting on the NetPrints service. Now, I try to log into through my VPN to my VPN server, but I start getting an error. And this is pretty small, but essentially this is saying, please contact your remote server's administrator to figure out what really the problem is. So I have a NetPrints client running in the background, which I open up, and I say, this is my application. I don't even, right now in the prototype, we just grab the application name from the state of the application, the running application. And so this thing here says the application name is IT Connection Manager. This is the IP address of my NetPrints server. And this button just says diagnose. So I can click on this diagnose button. When I click on that diagnose button, I essentially collect all the configuration information that's relevant to me, and I ship it off in an XML file to the NetPrints service. Now, the NetPrints service checks this with the knowledge base it's built, and it says, oh, your PPTP pass parameter was set to 0. You need to set it to 1, and sends this information back to my NetPrints client. And the client actually does an automated fix. It'll fix the problem for you and just says, fix the problem by setting PPTP pass to 1. Please try IT Connection Manager again, and things should work. And so this works in some scenarios. It doesn't work in all scenarios, but this is an idea of what we like NetPrints to achieve in most cases. Just to describe what's happening under the covers for that scenarios. This is our system design. On the client side, we have configuration scrapers. We have an end host scraper which collects configuration from the machine itself. We have a router scraper which collects configuration relevant to the router. And then we have a network feature extractor which looks at the traffic coming in and going out of my computer and computes some sort of signature over it. And I'm going to talk about these in more detail later. Then on the server side, we have the knowledge base, which has configuration trees, change trees, and signature generators, and I'm going to talk about each of these. And then a diagnosis engine, which, given a configuration, the diagnosis engine will look through the knowledge base, and it will suggest changes to the client. NetPrints has two modes of operation. There's the normal mode and the diagnose mode. So let me just describe the normal mode to you. Periodically, the client scrapes configuration and the network features. It occasionally prompts the user for success or failure information. And once the user inputs this information, it sends the labeled configuration to the server. The server trains this knowledge base that I talked about in the previous slide with this data. By the way, if anybody has any questions, please feel free to ask. Oh, somebody has a question. Hi.
So, one of the challenges you mentioned beforehand is configuration information can be distributed.
Yeah.
Some of it could be this problem at the server end. So, are you assuming you have access to the server as well to get that configuration information?
Right. So we are trying to troubleshoot problems where the same user has administrative control over both ends. And we believe that that is the more common scenario in home networks. For example, let's say you buy a Sling box, or let's say you're trying to RDP into your home from your office. So then you have NetPrints running on your client, which is right now in your office, and you have remote desktop server running at home, which is also under your administrative control. So getting information from both sides is not an issue in such a scenario. So we concentrate on those, yeah. Okay, so this was the normal mode of operation, and then we have the diagnosis mode, which is, as I showed in the scenario slide, the user identifies the problematic application. The NetPrints client then scrapes the configuration and sends it to the server. The server uses the knowledge base to suggest changes using what we call a configuration mutation algorithm. And this whole process is actually automated, the configuration mutation, which is suggesting what configuration parameters to change. Now let me go into a little more detail into three aspects of NetPrints. The first is the configuration scraper. Now I've put up this table again here because this is saying there's configuration on the router that's of interest, there's configuration on the end host that's of interest, and also on the remote host that's of interest. So we have a router scraper which uses both the UPnP, Universal Plug and Play Protocol, and the web interface to scrape configuration parameters. Now, we actually ran into a lot of problems while building this configuration scraper, which is not really, much research, but there's no standard way of actually getting configuration from your home router right now. Each of them support their own web interfaces, their own variable names, so it wasn't very easy to do this, but what we ended up doing was essentially what we call HTTP request hijacking, where for every form on the home router's web server, we emulate a form.submit. And that form.submit creates an HTTP post message, which we trap, and we grab the key value pairs within that post message. That was the best we could come up with. Then the end host scraper scrapes information on both the local and remote host. Again, like Harsha brought up, that we assume the same user has control over NetPrints clients running on both sides. And in this case, we used our domain knowledge to decide what to scrape. That in itself is a difficult problem as well. Figuring out that you have universal configuration scrape, that's difficult. So we just scrape the interface specific parameters. So things like are you using wireless or wired? Do you have an IPv6 address or only an IPv4 address? And also things like is TCP Windows scaling turned on or off? We also picked up patches and software versions and the firewall rules. Yeah, question.
So one challenge in a home environment, I imagine, is as you have a large number of devices that have their own way of doing authentication to the device, that in order to enable NetPrints, the user somehow has to know all of their passwords and authentication information and be able to communicate that to you.
Yeah.
Which is fine if they had a simple kind of username password where they probably use the same one for all. But a number of these devices now, because it's too hard for users to do this, have some kind of one-step auto-configuration where a password is negotiated and the user has no clue at the end. It's shared between the piece of TiVo desktop software and the TiVo box, and you can look it up somewhere, but the user would require a level of sophistication to be able to plug in. It seems like a missing element is going to be some kind of standardization.
Right. Actually, that is a smaller concern. The bigger concern is how do you actually grab, even if you had that in place, how do you actually grab configuration from your TiVo or your Slingbox or your Xbox is not clear. So what you mentioned is definitely a problem, but just gathering configuration from all these pieces is also an open question. So right now we assume that, since we are scraping just the router and the machine, we assume that the user, in fact in our prototype, the user needs to give us the home router's username and password, which we can use. Failing which we use the defaults, which work 99% of the time. But,
and it's not the case that any of these devices speak SNMP and you could use that for...
Yeah, so we could do some of that, but the problem is, so some of them speak SNMP, some of them speak more, advanced forms of UPnP and give us an XML-based configuration. But they're all such cheap devices that you can't really trust what they're doing. So it's just better to do this, web scraping that we do. That's our experience. Yeah.
I was just trying to connect to Gmail, and from my end host, I was able to connect onto all other sites from my Firefox browser except Gmail. And from my Internet Explorer, I could connect to Gmail. So it was just bizarre, right? And it turned out it was some plugin that was installed there which had some parameter that was set that was causing that issue. So so that means that you're now going into configuration on not just Firefox, but all the plugins and everything.
Right.
So how would
currently,
like
that's a good point. So we are not scraping any application-specific configuration right now. So the plugin, the installation of a certain plugin that you mentioned is, I would put it in that category. It's application-specific configuration. Right now, these patches and software versions is more, what Windows Update does to your machine, really. So we could extend this to do what you mentioned, but where do you stop? That's the issue. So as I go on in the talk, I'll talk about something we did to figure out problems when you can't scrape configuration when you don't have that configuration information. And let's see if some of that answers your question. But right now, no app-specific configuration scraping is happening. Okay, so there's the... Stefan, how much time do I have?
It's about half past.
Okay, so I talked about the router scraper and the end host scraper, and then we also do this composition of local and remote configurations. So let's say you have a certain MTU value on your local side, and then you have a certain MTU value on the remote side. And let's say they are the same value, or one is greater than the other, or one is less than the other. So we trap this sort of comparison between two parameters in a Boolean variable in some sense. So you could, the MTU value, if it's equal, or let's say you could define the Boolean variable to say, is this MTU value is the local side MTU value less than the remote side? And so that would have a 0 or 1 value. And you would use this in learning too.
How many features do you end up processing in the end, like for each configuration?
So we use lots of feature reduction optimizations. So we don't compare every feature with every feature. So let me just give you a ballpark. In our experiments, we ended up doing about 7,000 configuration parameters, all total, including the composite features. So the router gives you roughly, I don't know, about 1,000 or so parameters, and the end host gives you another 600 or 700, and then we just put them all together. So it's not huge, but it's not small either. Yeah, I already told you. Let me just skip this. Okay, the second thing I wanted to talk about was server knowledge base. What do we really do to learn things on the server side? So we have per application decision trees constructed using labeled configuration snapshots. So we have all this configuration information we got from different users. So we have good configurations and we have bad configurations. We feed this to this decision tree learning algorithm called C4.5. It's well known in the literature for the last 20, 25 years. And that spits out a very interpretable representation of what your problems is. And so we call this a configuration tree. It's based on this static snapshot of good and bad configs. And then we also use something called change trees when you have hidden configurations, when you don't have access to all the configuration information that you would have liked to have access to. So let me start with an example of a configuration tree. So this tree tells us that when your PPTP pass-through parameter is set to 0 on a Linksys router, you're in a bad state. And by the way, this tree is specific for the VPN application. Like I said, they're application specific. This is also telling me if PPTP pass-through is set to 1 for a Linksys device, then I'm in a good state. The other thing that the tree tells me is that when my device is a Netgear, if my disable SPI firewall parameter is set to 0, then I'm in a good state. Otherwise, I'm in a bad state. And notice that this subtree is there on both sides. So essentially, this is it's a little counterintuitive, but this is just representing state for two different routers. So the leaf nodes will either be marked good or bad depending on how the path from the root to the leaf pans out for this particular application. This is an example of a tree that the NetPrints service automatically generated for the VPN, for the IT Connection Manager, which is our VPN client at Microsoft. This is with 7 routers. So think about that. For each of the 7 routers is giving you about 1,000 different configuration parameters. So that's a lot of stuff out there. And this is generated using roughly about 200 different configuration points, or yeah, maybe even more than that, per router. And we have essentially 1, 2, 3, 4, 5, 6, 7 branch points. So it's representing the information from 7 routers in quite a concise manner. And here I'd like to bring out, we had to introduce a couple of new things, new parameters values here. So you have typical parameter values like 0 and 1, and then we had to introduce a not applicable because some routers just don't have this variable name. And so whenever a router does not have this particular configuration set, you will take this branch. Is there a question? The other thing we found after learning this tree through all our experiments was this particular parameter that the tree learned. This is saying that if on your local machine the Ethernet speed is 1 gigabits per second, then you're in a good state. But if your Ethernet speed is 100 megabits per second, then you have this other tree that you need to look at. Now, this was weird, but later we figured out this is essentially happening because we had just 1 gigabit router in our test bed. So the tree algorithm could have learned the gigabit router name as this parameter, and it would have worked just as well. But because it's an automated algorithm, it just picked up Ethernet speed as the discerning parameter. So this goes to show that this tree is not really fully human readable, but it is representing correctly and accurately what is the information out there that we feed into the tree. Just showing how machine learning can really learn some counterintuitive things here. Now, the third thing I wanted to talk about is this configuration mutation algorithm that the server does. So the server, given a certain configuration, will actually mutate it. There's a mutation algorithm to figure out the minimal number of changes it needs to do to the configuration to fix the problem for you. So let's say this is your configuration tree for the VPN app, and this is your configuration, right? Your device is a Linksys router, and your parameter is PPTP pass-through is set to 0. Now, that means you're essentially in this state. But, yeah, so you could fix this by taking this route in the tree. So by turning PPTP pass-through from 0 to 1, you fix the problem, right? But An automated algorithm knows no better. It could just say, change your device to this WGR614, which is Netgear router, and then set your disable SPI firewall parameter to 0, and you'll be fine. So to the algorithm, it really doesn't matter. Both of them are equivalent as of now, right? But we know that changing your router and changing a parameter on that router is not as good as just flipping one bit on your existing router. So what we do for that is track change frequency. For each of these configurations, we'll see how often does this really change on an end user system. And, we should expect, we haven't, done a real deployment, but we should expect to see that bits like this, simple variables on the router, will change much more frequently than just the device information. So then we pick the mutation that is sort of, I won't go into too much detail into the actual metric we use, but we pick the root which has the maximum number of changes, let's say. We take a harmonic mean of these frequencies. Yeah.
So I'm curious, I know you said you haven't had a chance to actually deploy it at a large scale, but I wonder if that's actually true in the sense that if I think about a Linksys router, and most people plug it in, works out of the box, right? It's only the rare geek that twiddles a configuration and gets themselves in trouble. And it seems like in a survey of all of your users, you're more likely to find a diversity of access points than you are in Linksys routers that people actually reconfigured. But maybe I'm wrong on that intuition.
No, you're right. But what we monitor is for a certain user, how often does the user change their device? Or how often does...
This is the per user count.
Yeah. Okay. All right. Okay. Now going to, these configuration trees are not going to solve everything for you because the configuration tree is just as good as the data you feed it. So some configuration info may not be learned by this tree. So instead of ending up in a bad state in the configuration tree, even though you have a complaint about your configuration, you might just end up in a good state. And why is that? Couple of reasons for that. One is you may have insufficient data. So a new router enters the market or a new application and you don't have enough data to learn the configuration tree fully. Or you have hidden configurations, like you have an app-specific configuration that you're not trapping that is causing your problem for you. So what do you do in that sort of a scenario? That's when we decided we needed to use something we call change trees. Change tree is also a configuration tree, but we only build it considering configs for which this the universal configuration tree ends up in a good leaf node. And we track changes that a user makes to their config. So if at some point for a particular user, the configuration went from a bad state to a good state, we record that. So we are assuming here that the hidden configuration or the app-specific configuration that we are not picking up for that user does not change. But some configuration change they've made locally that we are capturing has fixed the problem for them. And so we learn a change tree just based on this user's, based on changes that this user has specifically made. And we attach a change tree to each of the good leaves in the configuration tree indexed by what we call a network traffic signature. So the network traffic signature is really a symptom or a representation of the hidden configuration or the best we can do to capture hidden configuration. So we look at the traffic going in and out of the machine, and these are the features we trap for it. For TCP, did you send 3 SYNs and not receive a response? Or did you send a SYN and then immediately see a reset? Or do you see a reset after no activity for 2 minutes? Reset after some data was exchanged. For UDP, did you send data and not receive any? So we have a set of these features, and they are right now just Booleans. And we capture this feature set for some time window within the NetPrints client. Now, for each of these network signatures, let's say 3 SYN was sent but no response was received. That was the signature of the problem that a user started with. Then they made some changes, and this signature went away. So we trapped that change, and we learned the configuration, these change trees just based on that change for this one signature. So then when somebody complains with a problem and they end up in a good leaf node, we check their signature and we say, okay, maybe it's this change here, this change tree should be able to suggest some changes for you. Because if we fed this data to the generic configuration tree, it might just get lost in the noise, and the tree might not learn anything at all. So that's the change trees, and this is what we've done to accommodate scenarios where we are not able to capture the configuration, the real configuration that is causing the problem. Yeah.
So then how do you know what the change is that that you should record if you're not capturing that part of
Right,
the...
right. Yeah, I should have been a little more clear there. So the root cause of the problem is a configuration issue that you're not capturing, the configuration parameter that you're not capturing. But as it turns out, some changes in configuration that you are capturing makes the problem go away. And an example of this is the MTU issue that I mentioned earlier. Some router near the remote end is dropping your packets because that router has a low MTU or it has a firewall or some filter which is not allowing packets larger than a certain size. You're not trapping that configuration. However, you know, if you use this technique, you know that if you turn down your MTU value to something smaller, then your packets will go through, right? So those are the sort of problems we are targeting. Yeah. So just to summarize the diagnosis process, we look for solution in the universal configuration tree for an application. If the traversal ends in a good leaf node, then we look for a change tree with the network signature of the problem. If a solution is found, we report it to the user, and wherever we can, we automatically fix the solution. Right now, we fix it if it's an HTTP parameter sitting on the router. We do the fix automatically. And if no solution is found, we just say, you know, we don't have a solution to your problem, or you really don't have a problem, and the problem is somewhere on the remote side you're trying to contact. We've evaluated NetPrints on our test bed. So like I said, we haven't done a big, large level deployment yet, but that's something we are thinking of doing. We've evaluated NetPrints on a test bed comprising of 7 different routers from 4 different companies. And we've experimented with 4 applications, each of which traps a particular scenario. So the VPN client traps a scenario where you're in your home network and you're trying to access a server which is in the internet somewhere outside, so you're going out of the network. The FTP client scenario is where you are an FTP client somewhere outside your home network trying to connect to an FTP server running within your home network. So this represents cases like remote desktop to your home network, or you're trying to connect to your Slingbox service in your home, things like that. Then there's file sharing, which is a completely intranet thing. So your client and server are all within your home network. There's no traversal, NAT traversal happening there. And then we've tried to evaluate Xbox as well, trying to connect to the Xbox Live service. So this is a separate device sitting out there, which you don't have access to, I mean, in terms of configuration gathering. But if the problem is because of a router issue, then we should be able to capture the problem. We also judged for robustness to mislabeling in the configuration trees, because it's a learning technique after all. So we injected mislabeled information, and we found it to be pretty robust to mislabeling. So 13 to 17% of mislabeling, just aggregating over all this, caused 1% error in diagnosis. Now you can tune this. If you say, you know, I don't want to do any more than 0.01% error in my diagnosis, you could tune your learning algorithm so that that's the confidence you have in your results. And we also found it's tolerant to skew in configuration diversity. So like Alex said, most of the time people don't change their configurations. They just stick with the default. Maybe they twiddle one thing here and there. So we wanted to make sure that when there's not much diversity, things still work fine. So we found that the tree learns things pretty fast and pretty well, even when there's a lot of skew. Now just going further, what next for NetPrints is a question that this slide tries to answer. So we have, in this is sort of an artificial plot. So we have problems sorted by the frequency that you see them at. So you would see, things like cable unplugged would be high here. And things like your wireless switch on your laptop is turned off would be somewhere here. Those are really frequent problems. And then, port forwarding turned off, or stateful firewall turned off, the stuff that I showed, would be somewhere next after that. So I believe that you could use rule-based diagnosis to solve the first, extremely popular problems. Then for the app-specific problems we have targeted, we think we can use shared knowledge-based diagnosis to solve these problems. But then there's this really long tail. If when I look online at all these problems people report, they're all very different. And so there are of course these, but they get resolved pretty fast. Somebody says, oh, you need to do this, blah, blah, and then it gets fixed. And they say, oh, thank you. But then there are all these problems where the thread goes on and on for multiple days because it's very specific to their scenario. So really, I don't think there's any solution yet to even try and resolve problems that lie in this long tail. But the impact of solving these problems, or even trying to pinpoint where the problem really is, I think that would have huge impact. So that's something I'm looking at doing, going ahead and taking NetPrints forward. So just to summarize, home network diagnostics is a very challenging problem. And this challenge is caused by the diversity of apps and configs and the absence of an admin. And NetPrints, our system, it leverages info from the community to perform this automated diagnosis based on decision tree learning. And you can get more information from our NSTI 2009 paper, or you can talk to me afterwards if you're interested. Send an email. And that's our website. That's pretty much it. Any more questions?
Would the NetPrints database be useful to manufacturers of home equipment to test their equipment or to see what problems people might expect to have?
Right. So the NetPrints database would definitely be of interest, post-manufacturing, like you mentioned. But what might, just related to that point is that a manufacturer of a device, somebody like Linksys or Cisco or somebody, even Microsoft, right, whoever creates a new application, if they could set up a test bed, and with every new device or new application that comes into the market, if you can just try different configuration values within that test bed and try to build the NetPrints knowledge base using the test bed, that would be a really good thing to do. Because then we wouldn't completely rely on community-based information to solve the problem. But what you mentioned is also true. Given that we are learning this from community information, somebody who builds firmware for routers could take this information and make sure that their firmware has the correct default values, for example, or resolves bugs that have shown up in the NetPrints database. So yeah, definitely that's of use.
Yeah, Ranjita, so it seems like a lot of the problem that you're diagnosing are of the type good or bad, can I connect or not? Do you have any notion of how, could you do performance related issues too? So meaning like my internet is not fast enough, or it turns out that, just as your MTU example, like turning down my MTU to half fixes the problem, but it may turn out that suddenly my throughput is also reduced substantially, or like effects like those. Yeah,
so we thought of this for a while, and performance just brings in, so with good, bad, it's bad enough, or it's difficult enough, even though it's a binary thing. With performance, you have all this other kind of context that comes in, and even more hidden configuration parameters. And sometimes performance problems are just caused, now, and then later they're gone. So it's very non-deterministic. So using something like this to do performance issues may be useful, but I think it'll take a lot more work to really figure that out. And we haven't done anything in that space yet with NetPrints. Stefan had a question?
Sorry.
So early on, you had two examples that were caused by problems with the MTU size. And in one case, the problem was caused by the fact that the MTU was too big. In the other case, it was caused by the fact that the MTU was too small, which points towards a natural potential issue that you could run into, which is, I mean, this is a classic problem with kind of hill climbing type strategies to solve a problem, that you could find yourself in a place where by solving one problem, by coming up with the easiest solution to one problem, that you in fact are creating another. And have you had experience with that kind of situation?
Well, we've definitely thought a lot about it. And we have a strategy to sort of not solve that problem, but at least be conservative in the fixes that we suggest. So along with all the information we are sending to the NetPrints server, we are also sending the list of applications that are tied or that the user wishes to diagnose if there's a problem. So then you could see for this application, I'll fix this application by increasing the MTU. But the user is running all these other applications. By increasing this MTU, am I going to stop the other applications from working? Right? So you could figure that out and give that report to the user or not suggest any changes based on that at all. Did that answer the question? Okay.
So, so it looks like you have two separate techniques, right? You have the decision tree and then you have the network fingerprint. Did you evaluate like how many of the problems they could each solve individually? And is there any reason to have like two techniques rather than maybe I don't know, a third technique to add to it?
Right. So we thought of it for quite a while. What we thought of was what should be our primary diagnosis technique? Should it be just this, throw all the configuration in, learn this configuration tree, use this configuration tree to figure out problems? Or should we find these network fingerprints at the first level itself, and once we have a match with a network fingerprint, we look up some knowledge base for that one fingerprint, right? And we decided to go with the former because we found that in most cases where there's enough information to learn a fix to the problem, there is almost a one-to-one mapping between the fingerprint and the fix. So we just decided, just go with the configuration tree fix. Now, go with the configuration tree as the first level diagnosis. Then, if the configuration tree does not solve the problem, use the network fingerprints as a second level or a more fine-grained level of fixing the problem. Now, your question was, do we have any idea of how many problems get solved either way? That's a difficult question to answer because we don't have this universal database of all problems in home networking. If we had that, we could say, using the configuration tree technique, we could solve 50% or whatever, some X% of these problems. And we could solve Y% with the network traffic signatures. But one inherent problem we faced in evaluating our system is the absence of such a universal database. The best we can do is look at forums, look at problems that people have solved, and recreate these problems in our lab. And that's what we've been doing so far. And the next level is to actually go ahead with the deployment. And we're really trying to, we have some people working on our code so that we can actually go and deploy the system and have people use it and collect more information. So I think I'll be able to answer your question only after we have something like that going.
Am I correct in understanding that this is seen as complementary to the forum approach because you can't really do, unless you're doing monkeys at configuration screens, you're not going to be able to find what the fix is, and this only keeps a database of what fixes have been found previously through the forum or all the other previous approaches.
Yeah. Well, even the forum, right? When somebody reports a problem on the forum, if someone else responds, it's usually somebody who knows, who has some domain knowledge, who either suggests changes or has said, I have run into the same problem and I fixed this by doing this, Or they suggest, why don't you try this? Maybe this will work. So we are trying to automate the former, which is, when somebody has already run into the problem and they suggest a change, it's much more higher confidence. It's a much higher, it's a change that has higher confidence associated with it. So we are trying to automate that. Now, if you have run into a problem which nobody has run into before, then for now, like I said in my future work kind of slide, it's open. There's still no solution. There's no automation possible using this sort of approach, at least there. So the forums are the right approach for that for now, in my opinion. Any more questions? All right. Thank you very much.